Hi friends, this is Srikant Pawar and you are watching Mr. Make. So the today's topic of discussion is slope and deflection for cantilever beam. There are a number of methods for calculating slope and deflection. But the simplest one particular for the cantilever beam today we are going to discuss is area method for cantilever beam. Now consider this is the cantilever beam fixed at one end. Apply the point load P at the free end having span of L. Now let us draw the free body diagram for the cantilever beam. This is point load P. This is span L. This is free body diagram for cantilever beam. Now the shear force diagram, as point load is acting, so the shear force diagram is a rectangle. This is shear force diagram. Now draw the bending moment diagram. For the point load, shape of the bending moment diagram is triangle. Here the shear force is equal to P. This is the value of bending moment, that is PL. Moment is equal to PL. Force P into L. This is the total span L. Okay. To use the area method, at least the necessary condition is that we must know the shape of the bending moment diagram. So let us calculate the bending moment diagram. So first one, we calculate the slope for the cantilever beam. Slope is denoted by theta is equal to area of bending moment diagram divided by EI. So the area under bending moment diagram is, this is the rectangle, so area of rectangle is half of base, that is PL, into length height L divided by EI. EI is the flexural rigidity. E stands for Young's modulus or modulus of elasticity, and I is the moment of inertia. This is so the final result is PL square by 2 EI. This is the slope for the cantilever beam. Now let us calculate the deflection. So deflection is nothing but the slope into the centroid of the bending moment diagram. So the formula for slope is area of bending moment diagram upon EI into centroid of bending moment diagram from free end. So slope is equal to area under bending moment diagram is nothing but triangle, so half into base PL into height L into centroid. This is the height L, so centroid is here, so distance of centroid is 2L by 3. divided by EI. So the final derivation is this 2 get cancelled by 2 PL cube upon 3 EI. So deflection is equal to PL cube upon 3 EI. This is simple method to calculate the deflection for the point load acting at the free end for the cantilever beam. Now consider the second one is here is the cantilever beam and momentum is acting at the free end. So the shear force is 0 and the bending beam movement diagram is this span L. So the bending moment, this is shear force diagram, this is bending moment diagram. For the momentum, constant moment M is applied at free end, so the shape of bending moment diagram is simple rectangle. So deflection is, so the now we calculate the slope for this process. So the slope is area of bending moment diagram divided by EI. So the area is M into L upon EI equal to ML by EI. Same for deflection is equal to slope ML square by 2 EI. This is for slope. Now same for this, we calculate the slope. Here is for here we calculate the deflection. Deflection is equal to area of bending moment diagram upon EI into centroid. Let us area of bending moment, this is the simple rectangle, so ML upon EI. For the rectangle, centroid is act as half of the length, so this is L by 2. So final deflection is ML square by 2 EI. Here we rewrite ML square by 2 EI. This is the simplest method to remember. This is the simplest method to remember the formula for the cantilever beam. So this method is useful for the objective type of question. If you are preparing for the GATE or the any competitive examination, this will be useful. Once you revise all this, you no need to any special preparation about this particular topic. Once you know the method, we can calculate at any time, any moment. Okay, thank you. And if you are preparing for any examination, then please subscribe our channel, Mr. Mike.